Hello, and welcome back to another episode of Kerbal Space Programming. Kevin here, and it has occurred to me that in this video, I don't think we're really doing much programming. Instead, we're going to wrap up some contracts. So we've got one here that it requires us to test this liquid fuel rocket at a certain altitude, and it's fairly low, so we're going to go ahead, we're going to create a probe, we're going to start with the probe core. Of course, it pops it up there. Let's bring that down, because we're going to make a very, very small vessel with the purpose of just testing this thing out so we can get our quick contract money, close that thing out, because we want to get a little bit more science and a little bit more funds, which will unlock some cool stuff that we can do in the future. So I'm just building out a really, really simple thing here. We've got a fleet booster that'll get this up to the right thing, and we've got all of these. Now remember, this is something back from the first episode. We used these automatic things. So we're going to grab an altimeter and plop that on there, and that will go ahead and fire a staging event once we reach a certain altitude. So I'm going to go ahead and tweak stuff here. We'll just set the altitude up, we'll play around with these things, because remember, we don't always have to do software. We don't necessarily need to write programs for at least these simple things, and a lot of times having kind of a hardware system set up to do things is a little bit more secure. There are fewer chances for us to go wrong. So we'll go ahead and just change the staging. There we go. So we'll fire the solid rocket booster and then fire off our engine. And let's see, last thing, we want a parachute so we can recover this. We're going, and you can see we're doing very few funds, but we'll set this to only deploy at a relatively high atmospheric pressure and add a launch clamp so that we can actually go ahead and launch this thing. So obviously these are not the most glamorous of the missions that we run, but we want to grab finish out these contracts, because as soon as we unlock or finish those, we can complete even larger contracts, which will involve cooler stuff, because once we get more science, we can unlock things like docking clamps, which I think we'll be able to start playing with in the next episode, because some of kind of the newer program related stuff is really going to require that sort of thing, some docking clamps. And I'm just realizing that this okay, yeah, we are good to, are we good to launch? No. The one other thing, yeah, we've got to fix our staging, and let's also put some stuff on here for stabilization, because the altimeter action group thing is actually rather, it's either heavy or it's non-aerodynamic, but it causes a bunch of tilt. So we're just going to throw those on there to try and keep us somewhat stable. And that, let's see, let's just go ahead and throw, no, we're good. Okay. Yes. Okay, let's go. And off on our piddly launch pad, we are taking off. And you see, this thing does tilt over fairly significantly. And all we did is we just hit the spacebar to launch this thing, and hopefully it should run entirely automatically. And there we go. It's fired off its engine, which means that we get our contract, which gives us a very small amount of science, but more funds than we invested in this craft. And we can now just gently watch this thing fall back to Earth, which of course I'm going to time accelerate in post, because oh my goodness, that would take a while, and you have better things to do. And with that out of the way, we are off on another launch, shooting ourselves up into space once again on our very traditional launch stage that we've used in several previous episodes. Now, what's unique about this is that we are on our way to Minmus. So this is an unmanned capsule, though there is a capsule, because we need to rescue a Kerbal who has managed to get himself stranded around Minmus. This is, I believe, Gregory Kerman. And Gregory is my father's name, so couldn't pass up the chance to rescue the old man and show him that I've made something of myself. So there we are, just finishing up our circularization, and this is of course the fairly standard script stuff, and we see, yay, things are deploying, and we can begin looking at the code that we wrote for this episode. Okay, so the first script that we ended up writing for this Minmus Rescue one is stuff that we've seen all before. We're downloading the libraries that we know we're going to need. We set our ascent profile and we get ourselves up into orbit. This is all pretty standard stuff that we've done a few million times before, and I've locked some of the transmitters and stuff and the solar panels to the gear actions that we can go ahead and enable this. But this is all relatively trivial stuff. What is new, sort of, is our autopilot. And this is the most primitive autopilot that we have. And you'll notice that all of the instructions are actually set here in strings, and we're logging them out to startup.ks. We're doing this for a very particular reason. Remember how our boot script operates. So when we unboot, it's going to check and see if it has a connection to KSC. And if it does, it's going to say, are there new instructions? And if there are, it'll download and run them, right? Now, if there is not a KSC connection, or if there's not new instructions, it'll just go, okay, is there startup.ks? And if so, run startup.ks. And I'm just sort of pseudo-coding how this logic works. And otherwise, if none of those things are met, well, then it'll go ahead and wait. I don't remember how long we specified. Maybe it was 10 seconds or something like that. And then go ahead and reboot. So our boot up script constantly checks for new instructions. And then if it has no new instructions, it'll run the startup script. And otherwise, it'll reboot. And usually, we haven't actually had a startup script. It'll either be running the thing that we've currently uploaded, or it'll just be cycling, waiting for new instructions. But what we want to have happen with this script is we want this to actually go ahead and run regardless of whether or not the thing has rebooted. We don't want to have to re-upload this autopilot every time, but we still want to make sure that we can send up new instructions if for whatever reason the autopilot is broken. So let me go ahead and I'm just going to replace the quotes with nothing, and then we can look at kind of what this is doing, because this is what ends up getting written out to, there we go. This is what ends up getting written out to our startup file, so that way every time the ship reboots, if there aren't new instructions, it's going to go ahead and do this. So we're going to set our start time to right now, times seconds, and we're going to say until the RCS is on, wait a second, but if we get over 60 seconds from our start time, then go ahead and reboot. So go ahead and see if we've uploaded new instructions. This will go ahead and launch our boot script again and only drop into here if there aren't new instructions. Now, after RCS is turned on, it's going to wait until it has a connection to KSC, and then it's going to run maneuver.ks, which is a library that we've created that has all of those maneuver-y related functions, and then it's going to call maneuver execute node, which means that if we've put a node on our path, it'll go ahead and execute that thing flawlessly. Then it's going to turn RCS off and reboot. Now, the eagle-eyed among you may think that this is a little bit of cheating, and I agree that it kind of is, because basically what we're doing is we're saying, all right, from the map view, I can go ahead, create a maneuver node, and then just hit the RCS key, and it'll go ahead and run the thing. And I don't actually have to upload new instructions to the ship. This is kind of manual control, right? Well, yes. But I do have it set up so that even once we've turned on RCS, it's going to wait until it has a connection before running the node. So that way we're still dealing with the latency, but I don't have to re-upload this script telling it to, okay, go ahead, do the next one every single time. So this is a little bit of a hack, but ultimately that's how we're going to go ahead and do this, just because we're going to be executing a bunch of maneuver nodes. So let's go back and look at our ship. And as you can see, we have already set up our maneuver and done our time warping. This is a very simple mission because all we are doing is kind of hanging out in map view, setting up these maneuver nodes, and then hitting the RCS button. And conveniently, it will turn off the RCS when it believes it's done. Because there is that little bit at the very end where it starts to wobble around because there's a little bit left and the target you can see. Yeah, see, it's jiggling, it's trying to follow it, but eventually the RCS turns off and we have our encounter. So I'm setting up some various trim maneuvers and stuff as we make our way out there. It's nothing particularly interesting to see because this is the sort of thing that if you play KSP manually, you do sort of all the time. The only difference is that we are executing these maneuvers far more accurately because we are letting the computer do it for us. And let's see, we're just trimming ourselves down, getting into our orbit. There we go. Perfect. And RCS is off. And I did notice at one point that there's a little fault in the script, and that is that if we do not have a maneuver node and we hit the RCS, then the thing will crash. So I believe at some point, I probably cut this out. I think at some point I ended up having to reboot the craft. Though, of course, the way that KOS works, if you switch away from the craft and then jump back to it, the thing is going to reboot anyway. But yes, so there we go. We're getting our inclined orbit and trying to get ourselves down to somewhat reasonable of an encounter. We're not going to actually finish up the rendezvous from the ship itself because that's a little tricky with the shadows of radio connectivity. So we're going to let Gregory actually make his way over once we get ourselves near encounter. But I should also mention, while we're at it, that this is still running on KSP 1.04. There's been an update to KSP. Unfortunately, I recorded this footage an embarrassingly long time ago. There are also big updates to KOS. that we'll be talking about more in future episodes. But I believe we're, just about finishing up our circularization. We've got a really nice close encounter, and you can see, there we go, all of the... we get all of the alerts. The food is depleted and oxygen is depleted and all these things, because that's comes along with TAC life support. And the wreckage does not seem to have a lot of stuff. But we do have enough monopropellant that Gregory can start making his way over. It's always tricky because then the camera ends up switching around because we're going back and forth from playing with polar coordinates, where we're talking about kind of orbits and stuff, to all of a sudden we're in Cartesian coordinates, your XYZ stuff that you learned in high school math, which is, generally less helpful in space, because you really are talking about boosting your orbiter, shrinking your orbiter, setting up your Hohmann transfers and that sort of thing. But every so often when we get very close, we're going to go, let's go forward, back, up, down, left, right. That kind of makes a bit more sense. But yes, very, very excited about the recent updates, particularly to KOS. One of the things that they've added that I'm very excited to use is the lexicon, which is, if you've done any sort of programming, it is a dictionary or a hash, which basically, instead of having a list structure where you have a sequence of information, you can actually have key value pairs. So you can say speed is 5 and direction is 4, and then you could sort of save that as its own little data structure, and then say, okay, I have this data structure, give me this data structure's speed, and you can get things that way, which is really convenient for some of the stuff that we may want to be doing in the future. And we're getting very, very close. Come on. You see, we've got plenty of monopropellant left. That's one of the wonderful things about being around Minmus, is that it's such a small, gravity-less-ish body that we can do kind of just about everything. And of course then, just trying to orient so that we end up on the actual hatch. And boom! Gregory is rescued. And he is now disgusted to realize that he has been rescued by a machine. That is completely unacceptable to him. So he's going ahead, he's gathering the science that he can, because, of course now he is a commissioned member of our own space program. But before leaving, he has a little bit of an idea. Because, we are around Minmus, and we do need an awful lot more science if we're going to be able to play with cooler stuff like automatic aircraft and docking in space. We still don't have any docking ports, which means that building something like a space station is a little bit tricky. So Gregory has this crazy idea, and he's just going to go ahead and slow himself down. You can see the orbit there already decaying. Now, it's actually possible, and in fact quite easy, to land yourself on Minmus with very little monopropellant, doing this entirely on EVA. So he's going to go ahead and do that. Now, the one thing that's going to be tricky is that we don't have a ton of reserve fuel in the remaining craft, so we want to make sure that by the time we land, we're only going to spend a very short period of time. That way we know exactly where overhead we want to rendezvous to. That way, when we launch, we don't end up in some crazy eccentric orbit that's going to require a whole bunch of fuel for the craft to meet up with us again. But of course, we are very, very grateful to Gregory for taking this very stupid risk, trying to go ahead and land himself. And of course, it's just a matter of trying to kill off our lateral velocity and also make sure that we don't come plummeting down at too high a speed, though the Kerbals tend to be actually more resilient to high-impact landings than ships, generally. So, there's a shot. We can see, we're going to end up landing on a mountain, which means that it'll be less fuel for us to get down and to get back up, which will be great. But it's important that we gather kind of as much science as we can, because I think there are 3 kind of core things that we want to start working toward. One is trying to get actual aircraft set up. The other one is docking, as I mentioned, because then we can get space stations. We can start getting automatic kind of shuttles from low Kerbal orbit to, say, the moon's orbit, and then kind of periodically building on that, so we eventually have this whole transit system between the inner Kerbal stuff. And then, of course, we've got to start sending probes out to other planets. Now, we haven't done a lot of that because we simply haven't been in the right orbit. The phase angles with all the other planets is not quite there, because we're still only a few weeks into our space program, if you can believe that or not. And I think at some point we'll probably just time warp ahead because we'll be bored. But all the same, there's plenty of science to be had, both on the moon and on Minmus. And so this is our first manned landing, and not even an unmanned landing. And there we go. So we can go ahead, get our surface sample, get our EVA report, all that wonderful stuff, and even plant a flag. Alrighty. Put it down. This is for posterity, man. Okay. Yeah, just point it that way. That works. And there we go. Come on. Alrighty. So we have planted a flag. Wonderful. Get all of the remaining science that is to be had. And we can just barely see that in the distance. We want to make sure that we launch right away so that we end up in roughly the same plane. So rather than even use the RCS to launch us, we can jump and actually get a significant amount of velocity that way. And then it's just a matter of us chasing after this thing as much as we can. Now, we do want to be a little bit careful. We want to be somewhat conservative with our fuel because we want Gregory to be able to make the final rendezvous on this rescue pass. So we want to have a little bit left over so that we'll put him into a stable orbit. We'll get the ship back into an orbit where there'll be a near encounter, and then we'll go ahead and let Gregory finish up the rendezvous. Now, it's worth noting there's no way to actually script the Kerbal's movements, at least with KOS. It's possible there's a Python library that may allow that sort of thing, but the whole idea of this series is to automate the actual craft. And if the Kerbals want to go flying about being crazy, that is entirely fine. In fact, a lot of the science and stuff that we're doing, we're not necessarily automating because there were a few glitches with how that was working. Though, that's another thing that they've updated in the most recent KOS release, is that there's a separate module for just making the science way easier. You don't even have to pop up the little dialogues anymore. You can save or automatically transmit stuff, which is wonderful. You can run an entire mission and gather all the science without having to click anything, which is just fantastic. You can see, yeah, we're finishing things up. We've got ourselves up into orbit. We've still got plenty of monopropellant left. Now, we could have gone and done kind of the same strategy that we did with our landing on the moon, with our unmanned satellite. We could have done sort of a suicide burn type of thing, but, you know, it's a little bit harder to eyeball. Much easier to do when you're scripting stuff. So instead, we did this thing that's a little less efficient. We're running a little low on monopropellant, but we should be just fine. We'll go ahead and switch over to our craft now and try and set up a second rescue. Now, one of the things that we've kind of illustrated with this particular rescue is that a lot of the stuff that we scripted is fairly low level. It's things like execute a maneuver or get us to a launch or just write some text to the screen, that sort of thing. And that's really great. There's still some more things that we want to do, kind of building up low-level functions in our libraries that do things like docking and rendezvous and stuff like that. But eventually we want to start going into kind of a step above that, sort of a higher order library where we can say, I'd love to be able to say, okay, you're in this particular orbit. I would like you to be in this particular orbit with this apoapsis and periapsis around this body. And have it go, okay, and execute all the maneuvers to do that and get itself into the orbit. That'd be a really wonderful thing. I was actually, though of course there are other ways that you can go with that because even NASA doesn't necessarily do that. The space shuttle actually was set up with 4 separate computers that ran on tapes. And what they would do is they would go ahead and calculate all of these various things, and then they would simply compare the answers that they got. And what they set up to kind of have redundancy, they would set it up so that if one of the computers got a different answer, then they would say, okay, the majority rules, and then that 4th computer would just not be part of the mission anymore. Until eventually you got to a point, well, where there's only one left. And I believe that they got down to 2, then it was grounds for, nope, we have to land immediately, the mission is aborted, because we can't trust that the 2 computers we have left are always going to agree. And there we go. Now we're just going to go ahead and finish up our rendezvous on our nearest approach, and we're getting really close there. And now it's just a matter of trying to cancel out our relative velocity, and there's a lot of relative velocity to cancel out, but again, it is Minmus, so it's really not too bad. But yes, the NASA computers were kind of crazy. It's kind of crazy to think that you had kind of the space shuttle, which was running until, only 10, 15 years ago, running on these, relatively archaic computer programs. In fact, they actually would have to, much like with KOS, the computers could only hold the program for launch and orbit, And then the crew would have to go ahead and actually swap out the tapes in all 4 of the computers. And they actually did have a backup computer as well, if I'm remembering correctly, that they could fire up that I think was only capable of landing. Or maybe it was capable of aborting from a launch and landing. So it was kind of the everything is on fire thing. But you fire up, all the computers are down. Well, this one's fine. It's isolated from the whole rest of the system. And then you just boot that up, and then it's kind of the fail-safe. Now, obviously, now we've got much more sophisticated computery types of things. But there we go. Okay, so we are getting ourselves back into the capsule again. Now, there is an actual life support equipment attached to this, so that once he gets in, there's plenty of food and water and stuff to make his way back. And we're just going to go ahead and grab whatever science we can on our way before setting up the maneuver nodes that will bring us home. Now, yeah, just setting this up as sort of an autopilot makes this a relatively easy mission. All we're doing is setting up these maneuvers and then just going, go, 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 go. It'd be really wonderful if there was a way to kind of have it track. I mean, I suppose we could do that, right? We could say if there are 2 maneuver nodes, then fire the first one. So then we wouldn't even have to hit the RCS button. We'll just go ahead and update the mission plan as we go on. But yes, now we are coming in for a fiery landing, and this is all done with maneuver nodes. I think the last thing that we did, I think I let Gregory end up auto-staging, because that's just a single script that you'd have to write to, tell it to stage. But the parachutes, I believe, are set up to auto-deploy. We've tweaked the atmosphere at which they deploy, or the minimum pressure and the minimum altitude. It's important to remember to do that, because otherwise you can find yourself losing stuff. But there we go, lots of debris and equipment flying off, but we should have plenty. I believe there's a heat shield on here. And there we go. It's coming in for a nice soft landing and prepping us with tons of science that we can look at docking and flying around and going to distant worlds and other crazy stuff with newer versions of KSP and KOS in future episodes. So I will hope to see you then. Cheers.